learn math concepts such as the 4 basic arithmetical operations, working with fractions, and finding divisors. In the early 1950s, Cuisenaire popularized this set of colored number rods created by the Belgian primary school teacher George Cuisenaire, who called the rods rosettes. This is a 10 set of rods with length from 1 centimeter to 10 centimeters. Each length is painted with different colors. These are the color representations of the said rods. White is equivalent to 1 centimeter, red for 2 centimeters, light green for 3 centimeters, purple for 4 centimeters, yellow 5 centimeters, dark green 6 centimeters, black 7 centimeters, brown 8 centimeters, blue 9 centimeters, and orange for 10 centimeters. We will need this in our lesson.
Hello students, we will learn how to name a fraction using the Cuisenaire rods. The standard method in showing fractions with the Cuisenaire rods is by placing one rod of the ordered pair over the other to compare their size. The first rod of the ordered pair is the numerator, and the second rod of the ordered pair is the denominator. Take note that there are two ways in naming the Cuisenaire rods. One is vertical and the other is horizontal. For example, we would like to represent one half using the rod. First, we need to choose rods that will represent the numerator and the denominator of the fraction. In one half, 1 is the numerator and 2 is the denominator. Using this color representation, 1 is color white and 2 is color red. First, we will be using the vertical position. In one half, 1 is color white and 2 is color red. One half would be like this. The red rod is beside the white rod. Now, I will show you how to do it horizontally. The white rod will be over the red rod. Another example is 3/5. The numerator 3 will be represented by the light green rod, while the denominator 5 will be represented by the yellow rod. In this particular example, we will represent the fraction in the vertical position. We need to represent 7/10 using the Cuisenaire rod in the horizontal form. Using the same color representation, 7 is equivalent to black and 10 is equivalent to orange. Now, 7/10 in the form of the Cuisenaire rod is this.
Hello students, it's Ma'am Annabelle again. We are done naming a fraction now. With the use of the Cuisenaire rods, we will try to add fractions. First, we will add similar fractions. Given two fractions, 1/4 and 2/4, and we are asked to get a sum. Previously, you have learned how to name a fraction, so using this color representation, we all know that 1/4 would look like this, and 2/4 would look like this. Since the denominators are similar, we will just copy the denominators and then add the numerators. Looking back to the presented colors representation, 3 is equivalent to light green. That will lead us to the final answer, which is 3/4. Another example is 2/5 plus 2/5. As what we did in the first example, we pick the appropriate rod that will represent the fractions to be added. For the first fraction, the numerator 2, which is red rod, and the denominator is 5, is represented by the yellow rod. Since the fractions are similar, it implies that the representation is also the same.
You have learned adding similar fractions. The next thing that we will do is subtract similar fractions. The steps in subtracting similar fractions is the same as the steps in adding similar fractions. The only difference is the operation that we'll use. For example, we would like to subtract 26 from 56. For the first fraction, the numerator 2 is represented by the red rod, and the denominator 6 is represented by the dark green rod. And in the other fraction, the numerator 5 is represented by the yellow rod. Is represented by the dark green rod.
Since the denominators are similar, we can just subtract the numerators. In subtracting, it is quite confusing, so you have to listen and follow carefully. Obviously, the yellow rod is longer than the red rod, so we have to make a train. Starting with the red rod, make a train that will make the minuet and subtrahend equal. The added rod will be the difference of the two given rods. Not to forget to copy one of the denominators. In symbols, it will be equivalent to this fraction in which light green is above the dark green rod.
We are done adding and subtracting similar fractions using the Cuisenaire Rods. So, the next concept that we need to show is adding and subtracting similar fractions using the Cuisenaire Rods. Before we add or subtract the similar fractions, we need to find first the LCD or the least common denominator of the fraction. In finding the LCD, we need to master how to use the train. For example, we want to get the sum of 4/9 and 2/3. These fractions do not have the same denominators, so it suggests the need for the LCD. In getting the least common denominator, we have to make a chain. 9 is equivalent to blue rod, and P is represented by the light green rod. So, we have to make chains that have the same length. This is the visualization of what I am talking about. 3 light green rods and a blue rod have the same length, which is both 9. Now, the 9 is represented by the blue rod, which is now the LCD. We already know what the LCD is. Now, we need to find the numerator with respect to the LCD. The original fractions are 4/9 and 2/3. Now, we are to multiply the numerators with the times their respective denominators were trained to find the equal length with the other fractions or the LCD. In 4/9, the denominator 9/2 was trained once, which implies that the numerator 1 will be multiplied once, and 1 times 9 is equal to 9. In the same manner, in 2/3, the denominator P was trained thrice. So, the original numerator 2 has to be multiplied thrice so that it will be equivalent to 6/9. problem here is not just get the LCD, but we also need to find sum. Since we found the LCD, we are now ready to answer the problem. We just add the numerators 4 and 6, which is equivalent or equal to 10. Then, we can just copy the LCD, which is equal to 9.
Learn how to add and subtract similar fractions. You're also done adding the similar fractions. So, next is to subtract the similar fractions. Subtracting this kind of fraction will also need the concept of LCD. For example, we are asked to subtract 1/2 from 5/6. First, we need to refer to the color representation, then find the LCD. 1 is white and 2 is red. On the other hand, 5 is yellow and 6 is dark green rod. Make a train of red rods until it will have the same length with a dark green rod. We need not to make a train of dark green rods since 2, the red rod, is a multiple of 6. Just as what we did in the previous discussion, we need to multiply the numerators with the times we train the rods, then copy the LCD. In 1/2, we trace the red rods thrice to equate the dark green rod. So, 1, the numerator times 3 is equal to 3. The new fraction will be 3/6. The 5/6 will remain the same because we did not make any trade with it. Now, we are ready to subtract the fraction. We need to make a trade with the numerator of the subtrahend, which is 3, to the extent that it will be equivalent with the numerator of the mean one, 5. It can be shown this way. Since the red rod would make the two numerators equivalent, red rod over the dark green rod will be the difference of the given fraction.
Now, our discussion is over. It is your time to do it on your own. Explore and you will discover more. This short presentation isn't enough for you to be free from misconceptions and misunderstanding on fractions and its operations. So, I will give you the principles in making your own Cuisenaire rods for you to be able to have a first-hand experience on the manipulation of this turning tool and be equipped with the correct knowledge. Here are the principles in making your Cuisenaire rods. The Cuisenaire rods differ in sizes and colors. Always put in mind the color representations for each length. Here is a summary of the color representation. White is equal to 1 centimeter, red for 2, light green for 3, purple for 4, 5 for yellow, 6 for dark green, 7 for black, 8 for brown, 9 for blue, and 10 for orange. We all know that there are 4 fundamental operations in mathematics, which are addition, subtraction, multiplication, and division. Haven't you noticed? We only included 2 operations, addition and subtraction. Now, I will leave a challenge to you. Since you have made your own Cuisenaire rods, it's time for exploration.
define a process and how to come up with the product or quotient of two or more fractions by utilizing the Cuisenaire rods. I will give you a hint. Multiplication is considered to